Okay, today's section is section 2.3. How do you graph equations of lines? So in this section we're going to look at graphing equations of lines that are in slope-intercept form and ones that are in standard form. So let's start with slope-intercept form. Slope-intercept form is in this form: y equals mx plus b, where m is the slope, b is the y-intercept. We're pretty comfortable with that. It could also be written in function notation. F of x equals mx plus b as well. That's the same thing. Okay. Let's first talk about the term parent function. That's a term you'll hear throughout the school year. The definition of that is it's the most basic function in a family. In a family of functions. So for a line, the parent function for a line would be y equals x. It's the simplest equation of a line, or function notation f of x equals x. If it happened to be parabolic, it would be y equals x squared. It's the simplest parabolic function. So that's a parent function. So if we're going to graph in slope-intercept form, we follow the steps that are on page 90 in your textbook. It's written out pretty comfortably, and I've got the text right there so you can see what that is. So step one, we're going to write the equation in slope-intercept form by solving for y if it's not already in slope-intercept form. Identify the y-intercept, which is b, and plot it. Identify the slope and use the slope to plot a second point. And then finally draw a line through the 2 points. Okay, so let's apply that with an example. Let's go with y equals negative 3/4 x plus 2. Okay, so let's start by drawing an xy axis. Okay, so my y-intercept is 2. I'll plot that at 0, 2. My slope is negative 3/4, so that means the rise is negative 3, the run is 4. So down 3 over 4. 1, 2, 3, 1, 2, 3, 4, and that locates a new point. Now remember, you're traveling from the y-intercept, not from the origin. That's a common mistake. Okay, finally connect the dots. Boom. Put some arrows on the end because the line continues in both directions. Okay, let's try one more. Y equals 2x minus 5. Okay. Y-axis. Y-intercept is 0, negative 5. Extend this a little bit. Slope is 2, so that's the same as 2 over 1, so we go up 2 over 1. Rise over run. Collect the points. There we go. Okay, so that's how you graph if it's in slope-intercept form. What I would like you to do is give 4 problems a try. I want you to do guided practice problems 1, 4, 5, and 8 in your textbook on page 90. If you don't have your book handy, I'll write them down right now. Number 1 is y equals negative 2x. Number 4, y equals negative x plus 2. 5 is y equals 2/5 x plus 4. And 8 is function notation f of x equals 1 minus 3x. So pause the video, attempt those problems, and when you start the video up again, I will show the answers. Okay, so you've had a chance to do those problems. Now I'm going to show the answers so you can check and see how you did. So number 1, y equals negative 2x. The y-intercept is 0 because there is no b. Slope is negative 2, down 2 over 1. Negative x plus 2, y-intercept of 2. Slope of negative 1, so down 1 over 1. 2/5 x plus 4, y-intercept of 4, up 2 over 5. And then 1 minus 3x. In this case, the y-intercept is the 1, the slope is negative 3. So here's the y-intercept, slope is negative 3, so I went down 3 over 1. Okay, so that is slope-intercept form. Let's move on to standard form. Standard form looks like this, where a, b, and c are just numbers. Okay, so in this case, the variables are all on one side. Okay, we graph these by finding intercepts. And the step-by-step process is on page 91 in your textbook, so I can slide that over here real fast. Okay, so it's page 91, using standard form to graph an equation. So if it's not written in standard form, you can write it in standard form. Identify the x-intercept by letting y equal 0. Okay, the x-intercept is when y is 0, and solve for x. Plot that point. Find the y-intercept by substituting 0 in for x, and then you've got your 2 points and you draw your line. So let's look at that a little bit more closely in an example. Okay, so let's graph negative 2x minus 3y equals 6. Okay, so this is standard form. So let's start by finding the y-intercept. So we substitute 0 in for x. Okay, so if I do this on the side, negative 2 times 0 minus 3y equals 6. This term pretty much disappears. So I have negative 3y equals 6. Divide by negative 3. I get negative 2. So negative 2, when x is 0, y is negative 2. That's my y-intercept. Okay. Substitute 0 in for y to find the x-intercept. So that term disappears, so I get negative 2x equals 6. Divide by negative 2 and I get x equals negative 3. So negative 3, 0. So x-intercept. Got my 2 points. That's all I need is 2 points. Graph that line. Okay, let's do one more. Negative x plus 4y equals 8. So what you can do, rather than substitute, maybe you can determine what it is just by looking at it. So if I substitute 0 in for y and I cover up that term, what would x have to be? Well, if negative x equals 8, x is going to have to equal negative 8, because negative 8 would be 8. So negative 8 is my x-intercept. Right over here. In this case, I could have scaled it if I wanted to. If I substitute 0 in for x, cover that term up, 4y equals 8, y would have to be 2. So 2 would be my y-intercept. Plot those 2 points. Draw your line. Should have put arrows on there. And that would be it. So it's easier to find the intercepts on standard form by just substituting 0 in for x to get the y-intercept and 0 in for y to get the x-intercept. Okay, so two more guided practice problems I want you to try are problems 11 and 12 on page 92. So number 11 looks like this: 2x plus 5y equals 10. 12 is 3x minus 2y equals 12. So, whoops, there it is. Pause the video, give those a try, and then unpause it and you'll see the answers. Okay, so you had a chance to do those two problems. Here's the answers. 2x plus 5y equals 10. So if I substitute 0 in for y, that term is 0. Divide both sides by 2 and I get 5 for x. Substitute 0 in for x. Y is going to have to be 2. So this is 0, 2. Sometimes you can see it by plotting those points. 0 here, 2 here gives me 10. 2 times 0 is 0, 5 times 2 is 10. Substitute 5 in here, 2 times 5 is 10. 5 times 0 is 0. Those 2 points work. 3x minus 2y equals 12. Substitute 0 for y, divide both sides by 3, you get 4. Substitute 0 in for x, divided by negative 2, I get negative 6. So there's my graphs on that one. Okay, get that out of the way. Last thing, a couple special cases. Horizontal and vertical lines. So you get a horizontal line if you get y equals some number. So, okay. So for example, if I get y equals negative 2, you can graph that. If I have a graph, where's y equals negative 2? Negative 2 on the y-axis is right here. So the graph of y equals negative 2 is simply a horizontal line that goes through negative 2. So, pretty simple. Vertical lines occur when xy axis here, I have x equals any number. So for example, if I got x equals, say, negative 5, if I go over it to where x is negative 5, which would be right here, x is negative 5 everywhere on this vertical line, so I can graph that as a vertical line. Okay? Back up to this one, y is negative 2 everywhere on this line. Doesn't matter what x is because x is not part of the equation in that case. Okay, so those are a couple special cases that you might see. Last thing, and you've probably seen this before, y equals mx plus b can be used to model constant rate of change problems. Here's slope is the rate of change, and y-intercept is the starting point, or the initial cost, or something like that. So for example, let's say I had an account online to download music, and it cost me $20 to get the membership, and it cost 25 cents to download songs. So an equation for that situation, if y is the cost, would be 25 cents times the number of songs plus my $20 membership. So that's how we can apply a rate of change to that. So that is section 2.3 on graphing equations of lines.